Welcome to this video on gearbox. So here we will be concentrating on sliding mesh gearbox. So first of all we have to understand why we need to have a gearbox in a vehicle. The engine will be rotating in a very high speeds, but it will be having a low torque. So in order to increase the torque we need to have a gearbox like this. For example, if you are moving a vehicle from its stationary position, it needs more amount of torque to move the vehicle. So at that point, what we will do is we will reduce the speed of the transmission and we will increase the torque, and thereby we will be giving more torque to the vehicle to move. Generally at low speeds the vehicle needs high torque, and at high speeds it will sufficient to have a low torque itself. So the torque requirement of the vehicle is satisfied by this gearbox by reducing the speed of the transmission. So let us see what are the components in this sliding mesh gearbox. Here we can see an input shaft. So from this input shaft the power from the engine is fed into the gearbox, and here we can see an output shaft. This output shaft is connected to the transmission, or it is supplied to the wheels, and inside this gearbox we can see three shafts, that is input shaft, output shaft and a counter shaft. This counter shaft is otherwise called lay shaft, and we can see many number of gears. Let us see how this gears working. This is actually a 3-speed gearbox. It is having 1, 2, 3 forward gears. So this is a 3+1 gearbox, 3 forward gears and 1 reverse gear. Let us see how this gearbox is working from its first gear to reverse gear. At first, if you want to engage the gear in first gear position, the lever will be moved towards this side. If the driver moves the gear lever towards this side, this gear number 5 will be moved towards the left hand side, and the gear number 5 and 4 will be engaged. This is the position of the first gear. So during this first gear position, what will happen? The engine will give supply to this gear number 1. From this gear number 1, the supply is being transmitted to gear number 2. From gear number 2, it is transmitted to gear number 4 and gear number 5, and it will be transmitted to the output shaft. So when this is happening, the gear number 1 is having lesser number of teeth and gear number 2 is having more number of teeth. So a gear reduction will take place. For example, if the shaft is running at 1000 rpm, the gear number 2 will be rotating at 500 rpm, for example, because the gear number 1 is having less number of teeth and gear number 2 is having more number of teeth. So thereby the speed is reduced. When it moves from gear number 4 to gear number 5, the same thing happens again, because the gear number 4 is having less number of teeth and gear number 5 is having more number of teeth. So what will happen? If the gear number 4 is rotating at 500 rpm, the gear number 5 will be rotating at 250 rpm, for example, and then it will be transmitted to the output shaft. So at first gear, as we have discussed, the 1000 rpm is transmitted to 500 rpm here, and that 500 rpm is transmitted to 250 rpm here. So thereby we will be getting a gear ratio of about 4:1 in normal gearboxes. And then in the second gear, first thing we have to do is we have to disengage this gear number 5 from this gear number 4. Then we have to engage gear number 6 to gear number 3 like this. So when this type of engagement takes place, the gear transmission will, the power flow will be like this. The power will be transmitted from 1 to 2 and 3 to 6 and to the output shaft. So when this thing happens, the constant gear reduction will be the same, 1 to 2 will be the same. Whereas here we can see gear number 3 is having more number of teeth than gear number 4. So here gear reduction will not take place that much which was taken place in the first gear. So in the second gear we will be getting some more speed and some lesser torque than the first gear. And in the third gear what happens? The gear number 6 is disengaged from this gear 3, and the whole shaft, the output shaft, is moved towards the left hand side, and these two clutches will be engaged. So what happens? The gear transmission will be directly supplied from the input shaft to the output shaft. So there will not be any gear ratio. The gear ratio will be 1:1. That means If the input shaft is rotating at 1000 rpm, that same 1000 rpm will be transmitted to the output shaft. So this is the top gear. So generally this top gear ratio will be 1:1 in most of the cases. In some gearboxes there will be the gear ratio more than 1:1, that is called overdrive. And when the vehicle wants to have a reverse, so what happens, this gear number 5 will be moved towards the right hand side and it will be engaged to the gear number 8. So now let us see, if this gear number 1 is rotating in clockwise direction, it will be turned to counterclockwise in the gear number 2. Again the 7 will be rotating in counterclockwise direction. Now the gear number 8 will rotate in clockwise direction. Again the gear number 5 will rotate in counterclockwise direction. So the direction of rotation is reversed. So by this we can achieve reverse gear in this arrangement. This is the way by which the power is transmitted to the output shaft when the reverse gear is engaged. So the reverse gear is achieved by introducing a gear called idler gear. So the gear number 8 is called idler gear. So by introducing an additional number of gear, we will be getting the reverse motion, but the gear ratio will be the same as the gear ratio in the first gear, because the gear number 5 is the same. Gear number 5 is used for first gear as well as for reverse gear. So the gear ratio will be the same for the first gear and reverse gear, but the direction is counterclockwise. And I hope we have understood how this sliding mesh gearbox is working. But nowadays this type of gearbox is not used. So let us see how the other types of gearboxes like constant mesh gearbox and synchro mesh gearbox are used. These are the recent types of gearbox which are being used in recent vehicles. We will see that in the next videos. Thank you.